Hi, my name is Daksh.
And my name is Abdul.
What you see here is a self-driving car in GTA 5 that Abdul and I have been working on for the past 3 weeks. Our project was inspired by a similar project done by a YouTuber called Sentex. We watched his videos and felt that we could improve on his work by considering a completely new and different approach to the problem. Our project consisted of 3 main parts: collecting data, training the neural network, and making our neural network play the game. Since there were no datasets available on which we could train our neural net, we had to collect the data ourselves. We decided to collect the data by recording the frames and controller inputs of our own gameplay. We achieved this by screen grabbing frames using a Python library called MSS, and reading controller inputs using a Python library called Pygame. We recorded our gameplay at 20 frames per second and collected around 4 hours of gameplay footage. After collecting the data, we began to test multiple neural network architectures. Our first experiment was to train AlexNet on our dataset. After 2 hours of training, we observed that AlexNet had converged to following the GPS on the bottom right corner of the screen and had ignored the rest of the frame. This experiment, however, made us realize that we might need a better architecture to solve the problem. Our next experiment involved trying different variations of ResNet. We found the ResNet to be very promising, and the neural network you see driving the video uses ResNet 50 as a feature extractor. We settled on ResNet 50 since we needed fast inference time, and ResNet 101, which is the next step up, was not fast enough for our application. Finally, we observed that while ResNet 50 was doing really well, it didn't have a good sense of speed and movement. To solve this problem, we introduced an LSTM cell before the final inference step. This vastly improved the neural network's ability to accelerate and brake appropriately. The neural network architecture that we finally settled on looks like this: ResNet 50 followed by an LSTM cell. The final step was to make the neural network drive. To achieve this, we modified our pre-existing screen capture code to get the input frames and emulated an Xbox controller in Python using a library called vjoy to use the neural network's output to drive a car. Our neural network learned how to overtake, follow the GPS, and slow down appropriately. It also does especially well while driving on the highway. The neural network, however, also makes its fair share of mistakes by crashing into cars and poles. It also does not know how to recover from its mistakes, which we believe is due to the lack of data on recovering from bad situations. That's enough talk. Let's see what the neural network has to offer.
So
We hope you found our results as exciting as we did. If you would like to know more about this project, detailed explanations and the source code are available on our GitHub page. Thanks for watching.